Okay. For the task number 2, configure VLAN communication. VLANs facilitate communication by logically segmenting a physical network into distinct virtual networks, allowing devices within the same VLAN to communicate as if they were on the same LAN while isolating traffic from other VLANs. VLAN communications are managed through VLAN tagging via the 802.1q protocol, which involves adding a VLAN identifier, which is 802.1q tag, to network frames, enabling switches to route traffic based on the VLAN membership of devices. In this task, we will configure VM communications to add VLAN tags and demonstrate VLAN connectivity. Okay, for step number 1, we are now connected to ACIDM01 and the Hyper Manager window is open. Okay, in the Hyper-V Manager window on the virtual machines, double click the VM1. Okay, maximize the VM1 window. Okay, then type sudo space ifconfig space at 0 space 10.0.0.10 space netmask space 255.255.255.0. Press enter. Okay, then type ifconfig space at 0. Press enter. Okay, so okay, we have to minimize this VM1 on ACIDM01. Okay, so next, double click to VM2 and then maximize ulit natin. And then we have to type sudo space ifconfig space at 0 space 10.0.0.20 space netmask space 255.255.255.0. Press enter. And then type ifconfig space at 0. Press enter. And then type ping space 10.0.0.10. Enter. Okay. Since the 10.0.0.0 slash 24 network contains both the 10.0.0.0.10 and 10.0.0.20 IP addresses, VM1 and VM2 can communicate directly with each other via ping. In the VM2 command line window, press Ctrl C keys to stop the ping command. To stop this, i-click lang ang Ctrl C. And then it stopped. Okay? So, okay, minimize na natin ang VM2. Okay. For step 11, for VM1, right click, right click and then select settings, select network adapter, And then click the checkbox enable virtual LAN identification. And then um, for VLAN identifier, okay, VLAN identifier type 10 and then select okay. Okay, for VM2, select right click, select settings, and then select um, network adapter, and then check this box. And then for VLAN identifier, um, type 20, and then click OK. Okay, so communication from the VM2 and VM1 and VM2 interface will now be tagged with the VLAN 20 identifier. Okay, so next steps, double click the VM2 and then, okay, let's type ping 10.0.0.10 and then enter. You can see the and then Control C keys to stop the ping command. As you can see, it's working. And then when I click Control C and it stopped. Okay, minimize it. Okay, for VM1, right click, select settings, network adapter, and then type 20. Then click OK. So this tags the communication from VM1 with the same VLAN ID that VM2 is assigned. Okay, let's double click VM2. Then let's type again ping 10.0.0.10. Enter. Working again. Yes. So since VM1 and VM2 are both on the same logical network, and the communication from both machines are tagged with the same VLAN ID, the two machines can communicate directly with each other via ping. In the VM2 command line window, press the Ctrl C key to stop the ping command. So, click ko ng Ctrl C, and then it stopped. Okay. So let's minimize it and right click to this VM1 and then select shutdown and also in VM2 shutdown. Okay, then close Hyper-V Manager. On the taskbar, select VM1 on this. And then we have to close it. Also the VM2. Okay. So exercise number 2, MTU, the maximum transmission unit, is the biggest data packet size in bytes that may be sent over a network. MTU enables the efficiency of transmitting data and is crucial for preventing fragmentation issues. Proper MTU configuration ensures that the data is transmitted optimally and without the need for packet fragmentation, contributing to network performance and reliability. In this exercise, we will explore the MTU setting for of a VM interface. So, okay, so for task number one, modify the MTU. Modifying the MTU involves adjusting the maximum size of data packets that can be transmitted over a network, often done to optimize network performance or accommodate specific network requirements. Reasons for modifying MTU include reducing latency, improving bandwidth efficiency, and ensuring compatibility with network devices that support non-standard MTU values. In this task, we will discover and modify the MTU size for the VM1 at 0 interface. Okay, step number one, we are connected to ACID M01. So on the taskbar, select Hyper V Manager. Okay, then right click the VM1, then select Start. Okay, so and then double click the VM1 and then type. Okay, so um, type if config at 0, then enter. Okay, observe the MTU is set to 15 bytes. Then type sudo if config at 0 MTU 1000, enter. Then if config at 0, enter. Okay, then minimize it. Okay, then right click VM1 and turn it off. And then close Hyper-V Manager. Okay, select VM1, then close. So we are done. We have completed the switching concepts practice lab. Understanding the concepts of switching, VLANs and MTU is pivotal for network administrators and engineers to design and manage robust and efficient modern network infrastructures. The ability to create virtual local area networks allows for logical segmentation, providing enhanced flexibility and security within a network. Understanding and configuring the MTU ensures optimal data transmission, preventing fragmentation issues and contributing to overall network performance. By completing this module, we have gained practical experience in creating virtual switches, configuring VLANs, and adjusting MTU settings in a Hyper-V environment. These skills are fundamental in the deployment and management of contemporary network solutions.